Hi, welcome to Precalculus. Today's topic is multiplying and dividing complex numbers written in trigonometric form. Here is a basic example. Two numbers are given, z1 and z2. These are complex numbers. They are written in polar form. We want to see how to multiply them. The procedure is extremely simple. I'll go through it once, and then main thing is to explain where does this idea come from. So the question is, what is z1 times z2, or what's z1 divided by z2? To multiply, we simply multiply the magnitudes or the r's. So 6 times 8 will be 48. So that's 48 here. The angle is a sum of the two angles. So if I have 2 pi fifth and 2 pi seventh, we might as well put the 2 pi outside and add 1/5 and 1/7. You just take a common denominator, 35, add up the two components, 7 and 5. So that's going to be 12 times 2 is 24, 24 pi 35th. So the angle here is just 24 pi 35th. And as we said, there is always the same angle in both spots. How about z1 divided by z2? Just as easy. We divide the radii of the two numbers. So it's going to be 6 over 8 or 3 over 4. And then we have to subtract these two numbers. So we are going to subtract. Let me write a different color. So if I'm subtracting here, I'm subtracting here, and I get 2. So it becomes 4 pi over 30. So 6, 8, and it's going to be 4 pi over 35th. So if you are multiplying the numbers, angles add up. If you are dividing them, the angles subtract. Why is that? Let's learn that and see if all the trigonometry we learned in the semester is going to help us with this topic. So if my page cooperates with me. Okay, I guess I got this page rolling. So let's go back and write two numbers. Say z1 is r1 times cosine of theta 1 plus I sine of theta 1. z2, suppose it's r2 times cosine of angle number 2 plus I sine of angle number 2. Question is, what is z1, z2? Of course, we multiply r1, r2, then cosine of theta 1 plus I sine of theta 1, then cosine of theta 2 plus I sine of theta 2. r1, r2, just stay outside, and then cosine theta 1, cosine theta 2. Imaginary times imaginary, I times I becomes minus sine of theta 2 plus I times, now we are going to multiply this real with that imaginary and this real with that imaginary. So what am I going to get then? I'm going to get cosine theta 1 sine theta 2, cosine theta 1 sine theta 2 plus the other one is sine theta 1 cosine theta 2. Now, what is this? Do we remember from identities for sum and difference? This is simply cosine of theta 1 plus theta 2. How about that one? That's obviously sine of theta 1 plus theta 2. And all of this thing is multiplying by r1, r2. So the rule that we said, multiply the radii or the modulus of the two numbers, add up the arguments or the angles of the two numbers, and that is what we have here. What does that mean in picture? In picture, it means the following. If you have, if this is Z1, which is R1 times, let's write in notation cis, so that it will be abbreviated. And then I have Z2, that is R2 times cis theta 2. So cis, we said cis of theta, it's just cosine of theta plus I sine of theta. It's just an abbreviated way of writing this. It is also same as e to power of I theta. When I want to multiply them, I simply multiply the two radii, and then I go ahead and look at these two angles. This is angle theta 1, this is angle theta 2. I find the sum of these two angles. I find out, for example, this is maybe theta 1 plus theta 2. I go on that direction and I go as far as R1, R2, and that's the product of two complex numbers. So product of the two complex numbers has two components. One is the rotation. These complex numbers rotate each other. So it's as if you're taking Z2 and rotating it by theta 1, or taking Z1 and rotating it by theta 2. So that's what happens to their angles, and their magnitude simply multiply. Same idea applies to ratio. So if I have Z1 over Z2, that is R1 cosine theta 1 plus I sine theta 1 divided by R2 times cosine theta 2 plus I sine of theta 2. I can write this thing as R1 over R2, and then to divide these two, I of course multiply with the conjugate we said. So this one cosine of theta 2 plus I sine of theta 2. I multiply both of these things by the conjugate. What's the conjugate of this? Instead of plus, all we have to do is to write minus I sine of theta 2 divided by cosine of theta 2 minus I sine of theta 2. Well, what happens? R1, R2, denominator is easy because it's our complex conjugate. So all I have to do is to square this and square that and add them up. And luckily, well, what's true about that? When I multiply them by the property of product of conjugate numbers, each component gets squared and added up. And that's just one. How about numerator? Complex times real times, let's multiply real times real, and this complex times this complex. So that's going to be cosine of theta 1, cosine of theta 2. Plus I times minus I, that's plus 1. So plus sine of theta 1, sine of theta 2, that's the real part, plus the imaginary sine theta 1, cosine of theta 2, and the other one is going to be minus cosine theta 1, sine of theta 2. Well, now what happens is that this denominator is just 1, R1 over R2. First one is just cosine of theta 1 minus theta 2, and the second one is I times sine of theta 1 minus theta 2. So division happens by taking the ratio of the magnitude, and we subtract the angle of the denominator from the numerator. That's same as saying, so if this is Z1 and this is Z2, and this is angle theta 1, this is angle theta 2. What I need to do is to back this up as far as angle theta 2, and the product is going to be on that, because now this angle is theta 1 minus theta 2. How far does it go? As far as the ratio of the two complex numbers that we had. So very simple problem to solve, but very significant in the sense of it gives us some understanding of what does it mean to multiply two complex numbers. So once again, what we have is z1, z2. This is main observation here. Product of two radii, then the angles add up. Similarly, here z1 over z2 is ratio of r1 to r2, and the two angles get subtracted. Okay, so we learned how to perform this operation. Let's take a look at some special cases. What if I had to multiply a complex number with itself? What happens then? So suppose z is r cosine of theta 1 plus I sine of theta 2. Well, z times z, same as z squared. That is, I'm multiplying this thing by itself. I made a mistake here, let me correct. It's always the same angles. So if I have r1 and r2, I would have multiplied them. Now both of them are r, so r times r is r squared. Next, I have to add up the two angles, so theta and theta, so that's cosine of 2 theta, and this is I sine of 2 theta. Is that right? In the same fashion, z to power of n is r to power of n times cosine of n theta plus I sine of n theta. So what happens is that the angle gets multiplied. In special case, if z, let's change the name, suppose I have w is just cosine of theta plus I sine of theta. So the radius is 1. What is w to power of n? The angle just multiplies by n. So if I have this complex number whose radius is 1, is that right? When we don't write it, it means the radius is 1. So if it is somewhere here at some angle theta, when I square it, it becomes 2 theta. When I cube it, it becomes 3 theta, 4 theta, and so on. So it starts rotating in that fashion. Okay, so until next time, where we are going to learn about taking roots and some more interesting items related to complex numbers. Until then, good luck and God bless.